Hello and welcome back. In today's video we are going to study what is a system and what are various types of system. This is a very important concept in thermal fluid science and in any other science as well. So we are going to cover this in this particular video. So let's start. So a system is anything, in simple language, a system is anything that is being studied, that's under study. So definition is a quantity of matter or a region in space chosen for study. So it contains two terms, two phrases, quantity of matter and a region in space. Both are shown here. For example, this is a glass of water. The mass of the water is fixed. This is a fixed quantity of matter being studied. For example, one kind of study we can do is it's at 25 degrees Celsius. We want to study how much heat is transferred, so that how much heat can be transferred so that the temperature is from 25 degrees Celsius to 100 degrees Celsius. So this is a fixed quantity of matter being studied. So this is a system. Another way is air is flowing, wind turbine is being rotated by this air. So this is a very complicated motion happening here. So in order to make the analysis simple, what we do is we consider this region in which the wind turbine is enclosed. Wind is coming from one side, leaving on the other side, coming at high velocity, leaving at lower velocity. We get the difference between the velocity, and we will use that difference in velocity to calculate how much the rotational power is being produced and all that. So in order to make this analysis simple, otherwise the complicated motion of air is involved, and the interaction between the air and the blades and all that, we consider only the incoming air's velocity, the outgoing air's velocity, and the difference in the velocity. And this kind of studying something by choosing a region in which the quantity of matter, which is air here, is not fixed. It is coming on one side, leaving on the other side. So systems are defined in two ways: one in which quantity of matter is fixed, and another in which quantity of matter is not fixed, but the volume is fixed. Quantity of matter is continuously changing. So this is the basic definition of a system. Now anything, so if this is a system, the system can be solid, it can be liquid, it can be gas. So if this is a system which is under study, anything outside the system is called surroundings. Now a system is separated from the surrounding by something we call it boundary. The separation between system and surrounding is the boundary. Now there are two types of surroundings. One is the immediate surrounding. It is the surrounding when system undergoes a process, like heat is transferred. System is undergoing a process by changing its state from 25 to 100 degrees Celsius. So when a system is undergoing a process, the part of the surrounding which is immediate to the surrounding, which is affected by this process, significantly affected by this process, we call it immediate surrounding. And the far surrounding that is not significantly affected by this process is known as environment. Now coming back to the boundary. Now boundary can be of two types. A system's boundary can be real or it can be imaginary. For example, consider this nozzle. For example, the water is supposed flowing through this nozzle. So there are two types of boundaries involved. One is this boundary, the surrounding boundary of this nozzle. This is the real boundary because there are real walls, actually real boundary. But this, when we treat this as a boundary and this as a boundary, because this becomes a control, this becomes the system in which fluid is coming on one side like this and leaving on the other side. So this system has 4 boundaries, let us say top boundary, bottom boundary, and these are real boundaries because there are real walls, and the inlet and the outlet boundaries, which are not real boundaries because there are no walls. This is just imaginary boundary. So boundary can be real, it can be imaginary. Also boundary can be fixed or it can be moving. Boundaries can also be moving. For example, let's take example of a piston cylinder device. This is a piston cylinder device. This is movable piston, and inside there is air or any gas. So this is a system. Now these boundaries, when this system undergoes a process, these boundaries are fixed because there are fixed walls for this gas. So for this gas, these are fixed boundaries because there are real walls of the cylinder. But this boundary for this gas is not fixed, it is movable because the piston is moving up and down. So this is movable boundary. These are fixed boundaries. Now this was about the system, surroundings, and the boundary. Now there are types of systems. Now system is divided into 2 types. One is based on this phrase of the definition, quantity of matter. When there is a fixed quantity of matter being studied, the mass of this system does not change, it remains constant. We call this closed system. Closed system, or we call it control mass because mass is fixed. Or we call it simply system. So the general term is also applied to the closed system as well. Now for the closed system, mass remains fixed. That's the important question. That's the important point. I mean to say mass is fixed, m is constant. So mass does not cross the boundaries. Like this another form of the system, mass crosses the boundary, it comes in, it goes out. But in case of system, mass does not cross the boundary, but energy does. Energy crosses the boundary. Now there are various forms of energy. The 2 forms that that are significant and that are relevant in thermodynamics, in fluid mechanics, are heat and work. Heat and work. So energy in the form of heat and work crosses the boundary, can cross the boundary, but mass does not cross the boundary. Such a system is known as a closed system, control mass, or just simply a system. Now a special form of the closed system is when energy does not cross the boundary either. Neither mass, by definition mass does not cross the boundary. Now if it is a special kind of closed system in which energy cannot cross the boundary as well, like heat cannot go in, cannot come out, we cannot push the system from the surrounding, cannot push the system, or system cannot push back on the surrounding. Such a closed system, special closed system, is known as isolated system. Isolated system. For example, we have thermos flasks in which we put suppose tea inside, we close it, mass does not cross the boundary, so it's a closed system. Now it's a thermos flask, the walls are insulated, heat does not leave, there is no significant heat loss or heat gain by that thermos flask. So, and also there is no work transfer, nothing is pushing, nothing is being pushed. So thermos flask is an example of an isolated system. No energy transfer occurs, no mass transfer occurs. Now another phrase in the definition was region in space. So this is the region in space that we choose for study. We consider properties at the inlet, we consider properties at the outlet, we take difference between the two, and that change in property tells us what is happening inside, or how much power is being produced, or how much power is being supplied, and all that. This kind of study, this kind of system which is studied in this manner is known as open system, because it is open to this matter. We call it open system. Open system. Open system, or like this, it's called control mass closed system, and open system is called control volume, because volume is fixed in this case, not mass. So this green, this blue volume is fixed. Volume is fixed, but mass is not fixed. It is going in, it's coming out. So this keeps on changing. It's known as control volume. Now, for a system, the boundary of a system is known as boundary, but the boundary of a control volume is known as control surface. Specifically, it is also known as control surface. We can call it boundary as well, but it has a special name called control surface. Now, this was this was two types of systems. One is system, and another is a control volume. Now, just like the boundary, system can also be, or a control volume. If we talk about control volume can be fixed in shape and size. It can be fixed in shape and size, like this. This is a control volume. The nozzle shape is fixed. The nozzle itself is fixed. Shape is fixed. Size is fixed. So it's a fixed in shape and size type of control volume. But the control volumes can be moving as well. For example, if this was a system, but if we let gas flow in, so this becomes a control volume. So this becomes a control volume instead of a system, because now we are letting gas in. So quantity of matter is no longer fixed. So this is the volume. Now this is the control volume, this blue line. When the gas flows in, it pushes the piston outwards. So this control volume will be moving type. So control volume, because this will move from, when it expands, gas expands, piston goes out, and our control volume is not fixed in shape or size, at least not in size. It is increasing in size. So control volumes can be fixed in shape and size, or they can be varying in shape and size. So this was all about system and what are two types of systems. And specifically, books refer to system in two ways, as I said, in general way and in specific way. When they refer in general to anything that is being studied, they call it system. And when they refer to a fixed quantity of matter that is being studied, in which no mass transfer occurs, only the energy can be transferred, that also refers to system. So we have to see the context, what the book is talking about. So system can specifically mean both types of systems, or it can specifically mean a closed system. That will be all for today's video. Thank you.